Hey guys, welcome to part 4. And this really is going to be just everything that was in parts 1, 2, and 3, but without going through what MATHia has to say. If you want more detail on the explanation for these 3 parts of the MATHia problem, go look at part 1, 2, or 3. Here we've got a linear function. I know it's linear because, man, it's a straight line. How many x-intercepts does it have? 1. Right there. How many y-intercepts does it have? 1. Right there. We should be able to label it. Now, if we want to talk about domain and range, let's talk domain first. As this graph moves to the left, does it ever look like it stops? Like there's a place where the graph just doesn't exist? Now, I know physically that looks like the line stops right there, but there's no reason for us to assume stop at that spot. We can just imagine, we can zoom out for forever. This graph will continue to the left for forever, no minimum x value. Same thing, the graph is going to, in essence, with nothing to tell us that it's going to stop like a dot on the graph, it's going to keep going for forever to the left. So the domain, all real numbers. That same logic is true for range. Down and up, domain is the lowest to the highest value, and because those arrows seem to go down for forever, the arrow's pointing down as the graph moves to the right, and as the graph moves to the left, the line is still getting taller and higher and higher. So the ranges up and down, is also all real numbers. I'm going to try to find an example for part 5 where that's not true. So stick around for part 5 if you have a question where the domain and range is actually not all real numbers. Thanks for watching. Stay tuned.